Amazon Braket provides an easy-to-use ecosystem for accessing quantum computers on the cloud. But it could take months to develop a working use case. Today we'll look at an Amazon partner, Quantum Computing Inc., and their Qatalyst API, which is designed to shorten some of those quantum coding tasks to under a week. Find out how in this episode of the Post-Quantum World. I'm your host, Konstantinos Kragianis. I lead quantum computing services at Protiviti, where we're helping companies prepare for the benefits and threats of this exploding field. I hope you'll join each episode as we explore the technology and business impacts of this post-quantum era. Okay, guys, so today we're going to be doing something a little different. For the first time, I'm going to have two guests on, so we'll see how this plays out. I'd like to welcome Richard Molds, who's the general manager of Amazon Braket, and Bob Laskowski, who's the CEO of Quantum Computing Inc., or QCI, as we'll be calling them. Thanks for joining, guys.
Nice to meet you. Thanks for the invite.
Man, it's great to be here, Konstantin.
So we'll get started with Richard. I want to talk a little bit about Amazon Braket. I mean, I'm sure my listeners know what it is, but if you want to just give us a little high level about the Braket ecosystem and where you see it going within a year or so.
Sure. We launched Amazon Braket nearly a year and a half or so ago, and we went generally available or full public access about 9 months ago, August last year. So Braket is the quantum computing service of AWS. It's one of three quantum initiatives, if you like, within AWS. So we're the public service. There's also a professional service engagement team, which we call the Quantum Solutions Lab, or QSL. And there's also a research and development center, which we call the AWS Center for Quantum Computing, which is located on the Caltech campus. So the Center for Quantum Computing is pretty much focused on solving some of the harder problems, understanding quantum hardware, understanding error correction, algorithmic development, that type of thing. The QSL is about really helping customers deep dive into algorithm exploration, and Braket is really about getting access to different types of quantum computing hardware and classical simulators as part of essentially a one-stop shop for either getting started in quantum for the first time or for researchers diving into whichever particular aspect of the industry they're focused on, whether it's building applications, inventing algorithms, researching error correction, or trying to characterize different types of quantum hardware.
So currently, people can access through you guys D-Wave, Rigetti, IonQ for the most popular offerings. Do you have any other hardware surprises coming along?
We're not announcing anything today, no, but we've been pretty clear up front that we want to give customers essentially a window into all of the available technologies for building a quantum computer. There's 6 or 7 ways you can build a device. They have different attributes in terms of performance and fidelity and connectivity and native gate sets. So huge variance, and it's likely that over time different quantum hardware will fit different types of problem spaces. So our goal is to create a shop window, if you like, so customers can access every type of quantum technology going forward, and maybe even multiple examples within a particular paradigm. So as you said, today we feature quantum annealers, superconducting qubits, and ion traps. Over time, watch this space. Our goal is absolutely to add different hardware providers to the platform, and it's a big community. There's dozens of companies and research labs that are building quantum hardware, and they're interested in working with Braket because they don't really want the hassle of building web fronts and managing customer interaction and running customer support teams. Generally speaking, these companies are, as they should be, populated by physicists to build really cool stuff. So we hope to avoid a lot of the heavy lifting of trying to run a public solid service and allow them to focus on what they do best, which is building hardware.
Yeah, and in a few moments we'll be talking about a software partner. Basically, yeah. So some customers right now, including financial services, they're not doing many cloud workloads. As strange as it is, people think that everyone's in the cloud, but I guess there's still some sensitive things that they try to keep in-house. Are you guys already giving some thought to how they can access quantum if they don't already have sort of the buy-in and the cloud space?
I think it's interesting that that quantum computing might be the first step into the cloud for quite a few companies. You're right. There's a long way to go in terms of thinking about mass adoption of cloud computing. It's obviously been a huge trend for the last 15 years or so, but still lots of companies still contemplating that shift. They think very clearly about handing over some of the operational aspects of managing their own customer data. So it's been an extremely important message for AWS since day one to convince customers that it's safe to move to the cloud, and that your cloud provider can be trusted, and your customer data is safe, and that you have control over that data, and you can comply with whatever regimes are relevant in your industry. So that's a big part of the cloud message. Quantum computing almost sort of, as I say, may end up being a quantum first technology, may end up being a quantum only technology. So as quantum computers become useful, and it's particularly interesting, of course, to financial services who are deep into the business of optimizing portfolios from either risk or return perspectives. I think it's inevitable that at some point they'll sort of have no choice but to come to the cloud, if only to use a quantum computer. So it's it's interesting that a good deal of the customers using Amazon Braket today have never touched the cloud before. We have a lot of users that are very cloud centric and they're learning quantum computing, and we have a lot of quantum computing experts that are trying to figure out the cloud. And that gives us a double challenge of trying to communicate to both audiences and try and make it easy from both different perspectives.
Yeah, and what we're hearing, because they're so concerned about security and IP, we've already started talking to customers about what we could do with proofs of concept. Can we tokenize the data so it's sort of meaningless when it goes up there and it makes them more comfortable? But at the end of the day, the algorithm itself could be at risk, right? Like maybe they came up with a unique way of solving a problem that they don't even want to send that to the cloud. So right. Is there anything you tell customers about security there? Because you guys were way ahead of sort of post-quantum crypto in implementing things like hybrid handshakes, right? Between like Bike and Psych and ECC. Right. So do you guys kind of play up that angle to give them assurances, or?
I mean, security is, of course, a broad topic. It's all about links in the chain, and the weakest link, can bring down everything if you're not careful. So as I say, this has been a huge priority for AWS. And in fact, before I joined the Quantum Initiative at AWS, I was on the security side managing the encryption capabilities in AWS. So yes, clearly we focused on how do you get information to the cloud safely, and some of the post-quantum algorithmic work you mentioned is all about addressing that problem. Dealing with the threat that a quantum computer might one day be able to be able to expose the secret keys associated with public key cryptography, which is the primary mechanism by which SSL TLS connections work to the cloud. So that's a big initiative. Obviously initiatives to protect the physical infrastructure of the AWS environment, and then building, in many ways, more importantly, building in the internal controls to establish mechanisms to really minimize the touch points that AWS staff have over that data. We invested a lot of time and trouble with compliance reporting. So, for example, we defined a SOC 2 report that we publish every 6 months, independently audited, where we define for each service in AWS the degree to which any internal staff have any access to customer data, whether that be customer identifiable information, or whether that is intellectual property. So, big strides in terms of really locking down access even within our own infrastructure. So we're not just thinking about attack from outside. We're obviously focused on best practices in terms of guarding access to information inside. And international initiatives like GDPR, is really pushing the bar up in some of those regards.
Yeah, and this is probably a good point to segue over into one of the partners you're protecting and their property. So I'd love to talk to Bob for a moment here. And if you want to give us a little background on QCI.
Yeah, sure. I mean, and it's great to be on here with Richard. I think we're a great complement to the strategy that they have to democratize quantum computing. We're at the other end of that spectrum, looking to connect with as many clients as we can to make them available to QPUs. And our the business philosophy of what we're pursuing is that we want to bring as much quantum benefit to end users and make it as simple as possible as we possibly can. A lot of the access to QPUs today are via various toolkits or an interface that the vendors provide, but it doesn't make it particularly easy for end users to necessarily program for a quantum computer. You still need some pretty high-end resources. So we've developed a platform approach that kind of takes that component away and allows the end user, the subject matter experts, business users, to run problems either classically, which we can do today on the Amazon cloud, or quantumly. When that advantage is available, their problems that they run classically can be run on a quantum computer to achieve that advantage.
Yeah, so I was really interested in your Qatalyst approach. Of course, with a Q, right?
Everything is.
Everything has to have that.
That's right.
So it's funny, like you guys kind of threw me a curveball with this because for the longest time, I would describe the quantum ecosystem as everything's written from scratch. Everything's written from scratch. Everything takes, 6 months to develop. And then it's like, 4 days, right? So if you want to talk a little bit about that 4-day process that people can experience and how they can actually get their code running faster.
Yeah, sure. So, it's really just an API call. We've reduced a lot of the overhead coding to an API call that interfaces with it interfaces with at the hardware level, but there's a couple of other layers of software that we rely on. But it's but from an end user point of view, it's just a quick API call, and then they can run different problems. Now we focus on constrained optimization problems, right? So there are many different types of problems that quantum computers are good at. For the time being, we have an expertise and a ability to handle these particular types of problems, which run the gamut, supply chain logistics or drug repurposing and things like this. So there's quite a number of good business problems that we can help a client address with this. But we'll get to the point, and we're not quite there yet, but we'll very quickly, I think, get to the point where the user interface will be a UI that allows them to just define their problem, put their data into it, and run it through Qatalyst. And like I say, classically or through a quantum computer or in a hybrid approach. Because I think ultimately, as Richard points out, quantum computing in the cloud is not going to just be uniquely access to a quantum computer, but it's going to be a combination between classical and quantum.
Yeah, and I think personally that we're going to see the first advantage with a hybrid approach.
Right.
I think that's what's going to happen within this year, probably. We're getting like eerily close, especially on some of the D-Wave hybrid solutions. Mm-hmm. So when you guys are running a QBO, your backend target's obviously going to be a D-Wave, but you also have the ability to hit the other machines, right? That are present.
We do. Yep. Through Braket, we can access the D-Wave, the IonQ, and the Rigetti. And run those problems, but we can also separately run an IBM. And we're adding others as well. So our goal is to be as agnostic to the hardware as we possibly can.
Okay, so if someone wanted to access Qatalyst, they would go to Braket and then not be able to access IBM, or would they be able to still hop over?
So not through Braket. IBM is not running through the AWS cloud, but they could use Qatalyst to access the IBM machine separately. Okay. So that would be that's available to them, and for others, and however Amazon decides to bring on other QPUs, we'll continue to make those available through Qatalyst or separately.
Yeah, that makes sense. And did you guys start publishing sort of success results, like like papers more geared to showcase your interaction with these
Sure.
problem solving?
So the papers that we've been able to publish and have others publish have been based upon performance metrics to show that there's been a performance benefit. We're in the process now of actually collecting the use cases and demonstrating the efficacy of the approach through those use cases, but we're not at the point of publishing yet. And candidly, some, depending upon the client, we may not publish, but we're clearly interested in showing the validity of our techniques and the various use cases, to include, like I said, supply chain logistics and some risk analysis, particularly in the portfolio, but also as it goes back on the supply chain, looking at doing some stress testing and risk analysis on supply chains. That covers a really wide area. So there's a lot of good places for us to spend some time.
And are any of your customers already willing to like sort of shout out to the world that they're using this and having success, or are they being hush hush?
Everybody's at this point, I think we're not at that end result yet. So, and we take a very conservative approach, right? So we're not trying to hype anything. We're not trying to, get out in front of either a client or any successes we have. So we want to make sure we do it right. And at the right time, we'll be able to publish or to make an announcement that we've achieved some benefit there.
Okay, yeah, that makes sense. And when these customers are interfacing and using this, how do they then deal with the data that comes back, the answers? It looks like you guys have built a whole suite around also delivering the results.
Yeah. So interestingly, there's a couple of different types of clients that we're talking with and work engaged with. They're everything from the end user, the subject matter expert, to the consultants that are the experts themselves that are looking to bring that capability to their clients. So the results themselves are pretty straightforward. I mean, nothing magical about it. It's just a matter of providing them the data. And again, I don't want to get too far out in front, but this is very much a work in progress for us. I mean, as we work with the clients, there's not going to be a one-size-fits-all solution for either the front end that they'll look to putting data in, or the back end in which they'll be getting data back out again. So it's a good question, and I just don't think there's one answer yet.
And as usual, there's a stack, right? A whole software stack. So you guys are trying to abstract away as much of that as possible to try and make it just like as simple. So if someone did want to go in and like manipulate pulse level or something on a qubit, is that going to always be like locked out, or will there be some kind of like advanced interface available?
Well, for us now, we're not dealing at the machine level, right? So I don't think we'll ever, not in the short-term roadmap will we ever have a function that will allow that. There's a lot of good software out there that's doing that already, and we're just taking advantage of that.
Yeah, the users will probably just break it anyway. It doesn't work anymore.
Oh, there you go.
So are you guys also providing like any kind of training resources for companies that want to code in this environment? Like are like tutorials and things like that they can?
We are. Right now it's at a human touch level. We're not doing anything online, downloadable, but we're curating the process to be able to ensure that we understand the client. Again, you have to appreciate it's relatively early stage for us. So we like to have the client interaction to ensure that we understand how the clients are looking at the data, how they're interfacing with it, so we can refine our approach. So we are services oriented, although, I'm not, as we build out the model here, we're, a software company. You can never do without services. You never want to do without services, right? You always want to have that client feedback and understand what works well, what doesn't work well. You have to interface. But for the time being, the training we provide is of course being provided, by our technicians, by our services team.
Yeah, and because there's a little bit of that at least, and probably some proficiency to be gained, I wonder if then companies could start using your offering to, I guess, provide services to someone else too, like a go in between, Yeah,
absolutely. Like I mentioned earlier, part of our marketing goal is to work with other consulting shops, the big, euphemistically, the big 8, not the big 4, but that have that client contact. So it's great to be able to work with them, to train them up, and service them. And then, of course, they bring the expertise to the client.
Yeah, I have a feeling we'll be talking after this podcast. I mean, it's a very distinct possibility.
It is. It's great.
We're always looking for more tools to apply. We use abstracted things today, even just anything like Penny Lane, to kind of make user interface. So, yeah, I'm personally kind of interested in checking this out more. So here's a question for both of you guys. How close do you feel we are to advantage with both like what you're seeing in the hardware side, for Braket, and also this sort of like fine-tune approach with APIs? All right, do you guys have any experiments you're keeping an eye on that are getting eerily close? In a past episode, I talked to Sam Mugel from Multiverse, and they were able to show portfolio optimization at a dramatically increased speed. We're talking like 1,000 to 1. But it wasn't as accurate. So there's like that trade-off, right, of speed and accuracy and everything. So do you guys have any feelings on what you're seeing for advantage?
Do you want to go for that? I mean, you're the front end.
Yeah, I think so. So on the hardware side, I think we don't have the complete visibility of what's going on in the hardware space to the point where I could really answer that question confidently. But so I'll talk on the software side. I think the gains, as we kind of alluded to earlier, there are opportunities to, I think, maybe the word advantage might be a little bit too presumptuous or maybe too aspirational, but I think clearly some degree of advantage is probably an appropriate way to put that. I think we'll be able to achieve with software. I mean, clearly that's our goal. And I don't want to give out too much information on things that we're doing, but I would just say that we're very focused on that. I think there'll be opportunity to achieve much higher degrees of performance with software approaches than just purely hardware.
Okay. And do you see, this might be a question more for Richard, do you see anything being put in place for handling bottlenecks or access to machines? So, there's still only so few of them.
Right.
And as they get faster and people get excited, you're going to have everybody knocking on your door literally to to access these things. Have you started giving thought to how you're going to time slice those and make them actually usable?
Yeah, I mean, I think it's important to sort of jump on that issue. It's as you say, these are very scarce resources. Most of the folks that are building quantum hardware have one or two machines, and oftentimes customers are sharing those machines with the actual physicists that are trying to build them. So this is still very much an iterative phase of very limited hardware. From the outset, we decided to build Braket as an actual production ready platform. This is not just a showcase for one particular machine. We wanted customers, and we were told by customers that they wanted to be able to envisage what a production environment might actually look like. How you would control access to these devices, and how you would manage queues, and what a commercial pricing model might look like on these systems, and how you might deal with issues like QA, quality assurance. These are flawed devices right now. They sometimes generate the wrong answer. We should be honest about that. And it's important that we track that and we identify that to customers, and that we can manage availability. So that was very much in the forefront, so that as and when the hardware gets useful, advantage, as you say, there's a commercial infrastructure and a delivery platform that's able to scale quickly, because as soon as that advantage is proven, there's going to be a rush to consume this type of technology. Obviously, if somebody in financial services or somebody in material science or somebody in pharmaceutical does something interesting, then the rest of that entire industry will be extremely interested to follow suit. So I think we go from a research phase to a phase where demand might outstrip supply quite quickly. And then the industry sort of has to pivot. Today it's all about building one great machine, or the next generation machine, or the next generation machine, and claiming an improvement in fidelity, or claiming greater connectivity or number of qubits or whatever it might be. But quite quickly, the industry has to figure out how to build a supply chain that might have to physically build and manage, 1,000 of these devices and deliver them as a real infrastructure. So yeah, we're trying to get ahead of that a little bit and try and think about how we can um, envisage a production quantum computing platform, and I think that plays to some of the requirements that companies like QCI need. They're trying to build a business. They don't want to run their business on a collection of showcase technologies. They want to run their business on a solid AWS platform. So from day one, we decided this had to be a first-class citizen of AWS, and wherever possible had to comply with the mandates and the operational excellence bars that we set for ourselves and the security bars we talked about earlier that apply to any other AWS service. So yeah, very much thinking about that. And you said earlier, it's all about sort of hybrid for the next few years. It's not just about quantum computing. It's easy to fixate on the quantum hardware, but there's a lot of other components to this machine. Trying to combine together high performance classical compute, new development tools. You mentioned Penny Lane, which is the open source program for a project rather for trying to orchestrate better hybrid workloads, and trying to coordinate that resource with quantum computers, where quantum computers are available selectively, whereas classical resources are obviously highly elastic and highly scalable. So trying to orchestrate those different types of resources with different types of operational profiles, is not straightforward. So our goal is to make that as simple as possible for customers, so that fundamentally the technology can get out of the way and that they can innovate as quickly as possible on these platforms, and therefore get us to that point of advantage, hopefully, as soon as possible.
And are there any things that are in your control there? So like with D-Wave, they have their hybrid solution, and that's like kind of all boxed together. Do you guys also do sort of like latency testing to see if you can improve the transition from like more traditional AWS hardware to these, guest machines and back? Like, do you constantly work on that problem too, to see if you could create a new kind of hybrid? Or
absolutely. I mean, that's that's sort of the lifeblood of AWS. There's or most of the other services, are obviously growing incredibly fast, and that's their life. Operational excellence is a mantra around here in terms of managing scalability and latencies, and and that obviously follows into what we do as well. It's changing really quickly. As we evolve the deployment model for these different types of hardware, and every one of our hardware partners is different. They have their own different levels of operational maturity. The devices have very different characteristics in terms of performance. Even tasks like, for example, compilation, is handled differently for different types of machines. Compilation itself, can be an NP hard problem. So dealing with, these various different these workflow components, managing queues, just trying to make it predictable. What we hear from customers over and over is they just want a predictable experience. When they're ready to submit their problem, they want to know when it's going to get submitted, when it's going to get returned, and have some degree of visibility control over that. So it's very much an operational experience.
Because these machines aren't even really in your data centers, right? Like, yeah, they're sort of off being like housed and taken care of and coddled by their makers, right?
That's right. I'm not sure any quantum computers are in data centers quite yet in the normal sense of the word. I think they are. Yes, they're typically surrounded by people in white coats, and often are just the calibration cycle of these devices. It just, again, is different from technology to technology, but that's changing. I think the hardware providers that we work with today, do an amazing job. Not only are they trying to knock down huge scientific frontiers from an engineering and research perspective, but they really are working very hard on the operational aspects of their machines. Trying to minimize the downtime, trying to manage the the availability windows that they can make available, trying to be more responsive. When customers hit Braket, they have a problem, lack of availability. Say, we and the partners work together really hard to get those machines back online, and to bring them on and to make them available as quickly as possible. When a new device comes online, becomes available, it's vital that we get it in the hands of researchers as quickly as possible. So yeah, switching from device to device, maintaining resiliency across different machines, um, conveying the status to individual customers, relaying the current calibration data from every given machine and making that available to customers so that they know how long ago was that machine calibrated, what is the current calibration data. That stuff is extremely important to researchers. These machines are essentially unique. Even though they may have the same technology, every chip varies to every other chip. These are basically analog systems, and it's important that developers know explicitly which chip they're playing with and when that chip was last calibrated.
And when we do get to this point where one of these machines is doing something so great that everyone wants to do it, let's say it is running on something on Qatalyst. Will there be any kind of like sharing, or is it instantly like hidden away in private the minute a customer starts using Qatalyst, for example? Because I'm still wishing for more of a little bit more of a sharing thing to not stifle the industry,
Sure.
but I know that that's kind of naive to hope for the long term. So is there any kind of like shared library or something where people's successes that like you at least have the opportunity to share it with other, potential users of Qatalyst or anything like that?
Well, I think, to your point, Konstantinos, I think, the team that we have is very, they come out of the space where, sharing these types of advances is part of their DNA. And we would very much like to be able to accomplish that where, of course, we're maintaining the proprietariness of what we're doing. So I wouldn't say it's out of the question. People that gravitate toward quantum computing have a research background. They have very much a desire to be engaged in sharing the benefits of that research to the degree that they can. And I would support that, like I said, within the boundaries, I need to retain proprietary ownership of that information. If it doesn't meet that test, then we could go beyond it. But, so that's our DNA as well. We'd like to be able to do that.
Yeah, I think that's right. I think it's very important. We are very definitely in that research phase. We're not in the production phase where everyone's out to steal market share. This is definitely still the era where a rising tide floats all boats, and that's as Bob says, most of the folks in this industry have an academic background. It's in their DNA to share, and I think that's a tremendous attribute of the industry right now. That will change probably over time, but we're not there yet. I don't think this is our goal. One of the goals of Braket was just to bring the industry together. Hardware providers, algorithmic investigators and researchers, subject matter experts like QCI, customers, educators, consultants. Just give them a platform they can gather around and share. Was really one of the opening tenets of the Braket service.
Yeah. That's hugely important to me. I'm just nervous that the minute someone actually gets advantage, they're going to fall into a black hole and we're never going to hear from them again.
Well, that may be the case. Really, the fintech industry is probably going to be the most closed, right? Because and maybe even the pharma industry as well. But fintech clearly spending a significant amount of money to get that competitive advantage, and I can't blame them. They're going to be investing a lot of effort into it. But I think generally speaking, as Richard points out, this will be an industry that will be geared towards sharing.
Yeah. So, gentlemen, I really enjoyed this. Thank you so much for coming on. And the URLs are going to go in the show notes. But if you want to just tell listeners how they can find out more.
So if you're interested in QCI and Quantum Computing Inc., you can feel free to contact us. You can go right to our webpage. It's quantumcomputinginc.com. We have info@Quantum Computing Inc., and we're happy to respond to any inquiries there.
And for Braket, it's just aws.amazon.com/Braket.
Nice and easy to find. And I want to say Braket, but I always try to say Braket in my head because of the notation. I know, it's the physics thing. It's just I can't let it go.
I know. I get lazy, I suppose. So, half of our audience think it's a spelling mistake, and half our audience are so ingrained that they refuse to pronounce it any other way. So I sort of fall between the two, I suppose.
Yeah, it's a good marketing approach. Let's put it that way.
Yeah. So thanks again.
You're most welcome. Thanks a lot.
That does it for this episode. Thanks to Richard Molds and Bob Laskowski for joining today to discuss how Amazon Braket is bringing technologies like QCI's Qatalyst to the masses on the cloud. And thank you for listening. If you enjoyed the show, please subscribe to Protivity's The Post-Quantum World and maybe leave a review to help others find us. Be sure to follow me on Twitter and Instagram at Constant Hacker. That's Constant with a K, Hacker. You'll find links there to what we're doing in quantum computing services at Protivity. You can also find information on our quantum services at protivity.com or follow Protivity Tech on Twitter and LinkedIn. Until next time, be kind and stay quantum curious.